Hey guys, this is CHEMPLIFIED and today we will talk about solubility. So what is solubility? Let's take a look at that first. Solubility is defined as the maximum amount of solute that can be dissolved in specified amount of solvent at constant temperature is called solubility. Now first, what is solute and what is solvent? In general, if there are two components in a liquid, in a solution, then the component in smaller amount is known as solute and the component in larger amount is known as solvent. For example, if you dissolve 1 spoon of sugar in 1 glass of water, so the component which is in large amount is water, so water will be your solvent and the sugar will be your solute. Now, what is solubility? The maximum amount of solute that can be dissolved, the highest amount that you can dissolve in a solvent at a constant temperature. Why we are talking about temperature in this place? Because in general we all know that as temperature increases, solubility increases. For example, if I can dissolve 3 spoons of water, 3 spoons of sugar in water, in 1 glass of water, so, and this is the maximum amount that I am able to dissolve. But if I want to dissolve more sugar in water, then what I will do is I will increase the temperature of water and my solubility will increase. So in this definition, the temperature is constant because as temperature changes, solubility changes. So temperature remaining constant, at that time the maximum amount of solute that can be dissolved in a solvent is called solubility at that temperature. Alright, so this was your definition of solubility. Let's move ahead. Now, what are the factors which affect solubility? First of all, first one is nature of solute and solvent. What do you mean by nature of solute and solvent? Now, whether the two liquids or the components of the solution are miscible or immiscible. You can go like that. Or you can say whether the components are polar or non-polar, or one is polar and other is non-polar. These are the things that defines the nature of solute and solvent. For example, if solute is polar and solvent is non-polar, so the solubility will be very less, because we know that polar solvent are soluble in polar solute. Sorry, polar solute are soluble in polar solvent, and same goes for non-polar solute and solvent. So nature of solute and solvent will affect the solubility. Second one is temperature. We will talk about temperature in this video later also. So in general, remember that as temperature increases, solubility increases. In general, there are exceptions also. We will talk about that later. Now, pressure. Pressure does not affect the solubility of solid and liquids. We will talk about this later. But in case of gases, as pressure increases, solubility increases. Remember that, right? So these are the three factors which affect the solubility. One is nature of solute and solvent, second is temperature, and third one is pressure. Now let's move ahead. Solubility of solid in liquid. When solutes are dissolved in solvent, the following equilibrium exists. We will talk about the equilibrium later. What kind of solute we are talking? In this case, about which we are talking, it is solid solute. The solute is solid. When solid solute are dissolved in solvents, the following equilibrium exists. Solute plus solvent gives solution after dissolution. What is the meaning of dissolution? Dissolving, simple dissolving. Okay? All right. Now, solutions when converted back, solutions when solute is extracted back from the solution, the process is known as crystallization. We will take the most general example of sugar and water. When sugar is dissolved in water, dissolution occurs and we get a sugar solution, right? And when solution is removing the sugar particles from it, crystallization occurs and we get our sugar particles back. You should be familiar with the example when a sugar solution is heated continuously, the water will evaporate, and what will remain in the end is sugar. Sugar will not evaporate. This is crystallization, right? Now, this is the simple equation. Solute plus solvent on dissolution gives solution, and solution on crystallization gives solute plus solvent. Now, let's move ahead. Solubility of solid is affected by temperature. This was our temperature I was talking about. Solubility of solid is affected by temperature and pressure according to Le-Chatelier's principle. What is Le-Chatelier's principle? It simply states that whenever an equilibrium is disturbed, the equilibrium will try to shift in that direction, which will bring it again to equilibrium. This is your Le-Chatelier's principle. Now, in our case, if now remember this is we are talking about temperature in this case. If this solution is exothermic, if this solution is exothermic, let me show you again. What is this solution? When solute and solvent dissolve together, this solution occurs and we get our solution. So we are making solution by dissolving them. Now come back to the statement. When this solution is exothermic, what is the meaning of exothermic? Exothermic means when heat is evolved in a reaction. If this solution is exothermic, then solubility decreases. If this solution is exothermic, then solubility decreases. Why? Listen carefully. When we are dissolving a solute in a solution and heat is evolved, then if you increase the temperature, it is already evolving heat. If you increase the temperature, the solubility will decrease. The solubility will decrease. And move to the next statement. And if the process of dissolution is endothermic, then solubility increases with increase in temperature. What is the meaning of endothermic? Heat is taken into the solution. Heat is taken by the solution. Now, since heat is taken by the solution, it will increase the solubility. All right. Let me try to explain it in a different approach. If the dissolution is exothermic, whenever a reaction is exothermic, it simply means during the product formation, heat is released, which means the product is getting stabilized by release of heat. So the end product is stable, it releases its heat. It becomes stable by lowering its energy. Now it is already releasing heat, and you are increasing the temperature. When it is already releasing heat to get stable and you are increasing the temperature, this will leads to instability of the product and the solubility decreases. Right, now let's move to the endothermic reaction. What is endothermic? Endothermic reactions are those in which heat is absorbed by the reactants to get to reach to the product. Now, in an endothermic reaction, heat is absorbed to make the product, to make a stable product. So, in this particular case, solubility will increase because if you increase the temperature, the reactant will react faster to reach the product. So in both the cases, the solubility will be different, right? This was the second approach. I hope I made you understand. Now let's move to the next. Solubility of solid. This is just simple statement. Solubility of solid is not affected by pressure significantly because solids and liquids are highly incompressible in nature. So in case of solubility of solid and liquids, by pressure, by applying pressure will not be discussed because both are incompressible in nature and both are not affected by the increase of pressure, right? Let's move to the next. Now, solubility of gases in liquid. Solubility of gases is affected by pressure and temperature both. Now remember, these are the two important points. First one is increase in pressure increases the solubility. How it is possible? For example, there is a closed container and there are gaseous particles above the surface of the liquid, and there is a piston. There is a piston without weight. Now the condition is equilibrium. This is your solution and this is your gas. Now it is in equilibrium means the gaseous particles which were dissolved in the solution are coming up in gaseous phase, and from the gaseous phase the particles are going down in solution phase. Now if you increase the pressure by increasing the weight on the piston will come down and the space for gaseous molecules will decrease. Now more gaseous particles will hit the surface and get dissolved in the solution, and in the similar way more particles will be coming out. So ultimately the solubility is increasing by increasing the pressure. That's how you talk about pressure. Now increase in temperature decreases the solubility of gases. Now how is that possible? Let me first erase it. If you increase the temperature, remember the condition is same. There is a container, there is a closed container with solution phase and gaseous phase above the solution phase. Now if you increase the temperature, what will happen? The movement of particles in the solution will increase, and the gaseous particles which were dissolved in the solution will try to escape the solution more faster, right? If you increase the temperature, the gaseous particles that were dissolved in the solution phase will try to escape the solution surface quickly, right? So this will decrease the solubility of the gases in liquid. Now there is a note: during the dissolution of gas pressure of gas decreases and dissolution of gas is exothermic in nature. What do you mean by this statement? During the dissolution means dissolving of gas in liquid, the pressure of gas decreases. Yes, the pressure will decrease because from the from the the gaseous particles will try to dissolve in the liquid solution. The gaseous particles will try to dissolve in the liquid solution, right? So the number of particles above the surface will decrease, and as the number of particles decrease, the pressure will also decrease. Because what is pressure? The force exerted by the gaseous particles on the walls of the container. Now if the particles are decreasing, the average force exerted by the particles will also decrease, and hence the pressure of the gas will decrease. And the dissolution of gas is exothermic in nature. What is the meaning of this? That when the gaseous particle dissolved in the solution get dissolved in the solvent phase or the liquid phase, it is exothermic in nature, means heat is evolved in this particular case, right? So remember this statement: during dissolution of gas pressure of gas decreases and dissolution of gas is exothermic in nature. So this was all about solubility. I hope you understood everything. Thank you very much for watching.